Hello, this clip is about how to draw the benzene structure, which you'd be asked to do in exam questions. So when I say the benzene structure, what I'm talking about is how to represent the overlap of the p orbitals. In other words, how to draw out the delocalized pi system. So this is a picture from a textbook that shows the delocalized pi system for a benzene ring. So before we go any further, it might be worth making sure that you're aware of a few terms so that I can make reference to them during the course of the clip and you won't be confused by what I'm saying. So it's worth making sure you're happy with what the terms delocalized pi system and orbital mean. So the drawing in the middle of the page shows how the benzene ring is commonly shown in textbooks, although occasionally you might also see it like this, in a hexagonal shape with what appears to be alternating carbon-carbon double bonds. So if you look at some websites, just online, if you were to Google, for example, structure of benzene compounds, you might see quite a lot of images that have this, what apparently looks like 3 alternating carbon-carbon double bonds. Now we've obviously taught you that the Kekulé structure, which suggested this alternation of carbon-carbon double and single bonds, is actually incorrect. What the websites are referring to is the idea of resonance. So resonance is something that American chemist Linus Pauling proposed in support of Kekulé's theory. And Kekulé himself also proposed an idea of resonance to try and explain away the fact that his structure would react with bromine water when in fact benzene doesn't. So Kekulé was aware of some of the issues with his original structure. So if you look carefully, you'll see that if you were to number, for example, the carbons in each of the rings I've just drawn, you'll see that the double bonds actually switch around, and the double-headed arrow that I've put in there represents the fact that they switch back and forth very quickly. So what would the mechanism for this be? Well, it's quite straightforward. A pair of electrons from each of the double bonds would do this. And it would move back and forth between these two structures. The only problem is which one of them, if you could freeze frame that, which one actually represents benzene. If benzene is going to be a hybrid of both of them, so in other words, it's both of them and neither of them at the same time, that starts to complicate matters. But it doesn't mean that this isn't actually happening. So all these different ideas had to be pulled together into one accepted model. So like I said slightly earlier in the video, the photograph from the textbook in the top left-hand corner of the page is the current accepted delocalized model for benzene. So the next slide is going to show you how to draw this. So using the textbook photo as an idea to try and follow, you start by drawing a slightly flattened hexagon. So if we draw our carbon bonds on the ring like that, you'll notice the hexagon's been slightly flattened and stretched. We then put the hydrogens in, like this. So already what we're trying to do is set up a three-dimensional way of representing it like a photograph. The second step is to add the pi orbitals, the p orbitals. So what we need to do is to draw them above and below like that, taking a kind of teardrop shape. So you can see why we've made a flattened hexagon. It's to make room for the orbitals. The final step is to delocalize them by drawing dotted lines between them. That shows that they're delocalized and overlapped and connected. So as it's often a 3 to 5 mark rather, question to get you to draw this diagram, it's worth practicing, and it's also worth labelling it as well. So you can label the p orbitals, and you can also label the dotted line as showing delocalization.